So we're up to the second example. In the previous example, we didn't have acceleration in that question, but this one moves on. The next two do move on to acceleration, and they also move on to having a look at, we've talked about initially, but it's all going to also going to talk about things like eventually. Sorry, my sound isn't working, so I'm going to have to restart. Okay, Justine, so I'll keep an eye out for when you're coming back in. Okay, thank you. So yeah, the word eventually is something we need to do a bit of work on today and think about. We're going to be looking at graphs of displacement, velocity, acceleration, etc. And again, that interpretation of what they mean. Okay, so hopefully the two more examples that we have today will really clear things up for you. So this one here says a particle moves so that its height, x meters above the ground, t seconds after time 0, is x equals 2 minus e to the minus 3t. And the first thing they're asking us to do is to find the displacement initially and eventually, and find the velocity initially and eventually. So obviously for initially, I might divide the page in half, and on this side I'll do displacement, and on this side I'll do the velocity. So if we're talking about initially, then we're saying t equals 0. So for us, the displacement, and happy for you guys to be working on and having a go at those. So let me know if you need me to give you a chance to have a go at that. But we're just going to go 2 minus e to the minus 3 times 0. So that's 2 minus, that's going to become e to the 0 is 1. So you get 1, okay? And the units, we're up there in meters, so that's going to be 1 meter. But what do we now need to say that means?
1 meter above the ground.
Right. So therefore 1 meter above ground. Now this particular question is one, because you're talking about a particle moving so that its height, we're actually considering the particle moving. There's your ground, and the particle's moving up. Now, particle. So it's going to move up, and then it's going to come back down again. Okay. So if we then have a look at eventually. So what does eventually mean?
As t approaches infinity.
Yeah, so you want your time to approach infinity. You want to find out where it ends up at the end of time, okay? So in this particular case, we're going to say as t approaches infinity, then we're looking at our displacement. We've got x, and technically we're saying it's approaching, okay, because it's like a limit question. So it's approaching 2 minus e to the minus 3 times infinity. So that's 2 minus e to the minus infinity. Okay. Now, is that a massive number or is it a tiny number?
Tiny.
Right, because remember, if we have our exponential graph, even if I just draw, that one's got the negative in front, but just for the purpose of thinking about our exponential graphs, if I've got an exponential graph like that, and so it passes through at 1, when I head down towards negative infinity, what does this value approach? Where are we approaching? We're approaching 0, right? So that means that is 0. So we have 2. Okay, so there's going to be lots of questions that are going to crop up now. And if they're anything to do with eventually, then a lot of the time they're going to be exponential, because you're going to have something to a negative power. And so e to the negative infinity is approaching 0. Okay, so.
Wait, Miss, I got a question.
Yeah.
Isn't it because it's negative minus e to the negative power? Shouldn't it be like the other way?
That negative
graph?
part there.
Yeah.
You're
Should
going
the graph
to,
be
so
the other way?
the negative graph, so if I'd drawn the actual graph as, and we're coming up to that graph in a moment, all I was focusing on was what happens to e to the negative infinity.
Oh, okay.
Okay. So that's what I said, that graph doesn't match the actual function.
Yeah.
This is not graph of x. Okay, this was just looking at here being e to the minus infinity effectively, and seeing that it approaches 0.
Okay.
Okay.
Mm-hmm.
So again, we've got the 2, and so therefore it's going to eventually reach 2 meters above ground, because it's positive. So it'd have to, if it becomes negative, it'll be below ground. Okay, so if we're then looking at, so this was our displacement side, this is going to be our velocity side. So to be able to do the velocity, what are we going to have to do first? We've got
You have to differentiate.
Yeah, so we've got x equals 2 minus e to the minus 3t. But for velocity, we need to differentiate it. Okay, so when you differentiate the constant, it's going to become 0. When you differentiate this, remember an exponential becomes that same exponential, but I'm going to have to multiply by the derivative within, which is that -3. So the -3 times that negative there is going to make it +3. Okay, and that's our velocity. So again, if we want initially, when t equals 0, then you're going to have the velocity is equal to 3e to the -3 times 0. That part there becomes 1. So 3 times 1 is, oh, I wrote a 3 instead of an equals. And your units were meters per second. Okay. Now, which way does that mean we're going? If we're talking a +3 and we're dealing above ground, which way does that mean we're going?
You're going up.
Right, so we're going to treat up as being positive velocity, and we're going to treat the direction of down being negative velocity. Okay, anything above ground we're treating as positive x, anything below ground we'll treat as negative x. So if we then, so that's 3 meters per second moving up. Okay. Previously we've talked left and right. Okay, so now if we look at as t approaches infinity, then our velocity is going to approach 3e to the -3 times infinity. So again, e to the negative infinity is approaching what?
0.
0. So therefore 3 times 0 is 0. Okay? So eventually the velocity will be 0. And how do you interpret a 0 velocity?
It will be stationary.
Right. So I is stationary. So it's going to stop. Okay? Any questions there before I move on?
Yeah, I have a quick question.
Yeah.
So it's just going to float 2 meters above ground?
Float. Oh, right. Yeah. Yeah. We're talking about a particle rather than a ball. We're talking about something that's not, that is defying gravity. Is that what you're thinking of, Jake?
Yeah.
Yeah. Yeah. So that's why they haven't said a ball, because a ball is more likely to use the laws of gravity and come back down to ground. So we must be out in space or somewhere and we've got some particle, but yeah. So this one's not working in terms of normal laws of physics, okay?
Yeah, thanks.
Okay. All right, and we'll have a look at a graph of that in a moment too. Okay, any other questions? So here's a question I prepared earlier, part B.